Hello young people, here's our final video from chapter 1 unit 2 or lesson 2 rather. And in this video we are going to talk about models, not the pretty people in magazines. We are talking about scientific models. And a scientific model is simply a tool. We talked about that in our last series of videos as well. We're going to come back to models. We're going to use models all class, like until the end of the school year. We're going to use models. Models are just a tool to understand how systems interact with one another, or maybe to understand a single system. But it's a way to simplify a system so that we can understand it, or to help us understand it at least. Your textbook uses modeling the water cycle in California as an example. So there's a pretty little diagram in there that shows the Pacific Ocean, and there's a little arrow, and then there's some clouds, and there's another little arrow, and then the water. So the arrow represents evaporation, right? And then you've got some clouds. And then there's an arrow, and those clouds move in, and then there's some precipitation on the Sierra Nevada mountains. Well, that diagram is a model. It's a very simple model, but it's a model. It helps us understand the system and the interactions. We're interacting from the hydrosphere to the atmosphere to the perhaps cryosphere if the precipitation ends up being snow. And they show interactions between those systems. And a little bit of throwback to last lesson, because under normal years we've got that snowpack in the Sierra Nevadas is getting reduced. There's not enough water coming in, but then an El Nino year comes in to the rescue, and that extra warm winter causes extra precipitation, and California gets caught up on its water level. Between the text and the model, we can learn that from our textbook, between the paragraphs, the written words, and the diagram. So we start off with that model of the California water system. Models are super useful. They're really useful. They help us understand. And whenever things in science get hard, we want to create a model for ourselves. And models don't have to be complicated. Sometimes models are complicated. Sometimes models are a physical representation of a thing. But sometimes models can be as simple as a diagram with some arrows. Sometimes models can be pictures or maps or tables or graphs. We're going to talk about all of those. We started chapter 1, lesson 2 by talking about the ozone layer. And your textbook offers some beautiful images that model the ozone layer. Why do we need models to look at the ozone layer? What do you think? Think about that for just a sec. Why would you need some kind of model? Why can't we just look at the ozone layer? Why can't I look up and see it? The reason is because it's invisible. It's a gas. It's an oxygen gas. It's invisible. There's no way to see it. So if we want to know what's going on with the ozone layer, we need to use a model. So we can use some satellites, and we can collect all kinds of data. We could collect data points every single day about how much ozone is in a specific location. And we can collect all that data and we can build a table with it. And that's kind of a model. A table is kind of a model. Got rows and columns and all sorts of numbers and stuff, but it's pretty hard to see what's going on with the table. It's hard to see what those numbers show. So maybe we're going to take that table and maybe we're going to graph it. Maybe we're going to make a graph. Make an x-axis and y-axis, and we'll make a graph. And we might see what happens, say, over time. And that's a model. That's a pretty useful model. Graphs are extremely useful models. Maybe we'll take all of the subsystems and we'll draw a picture. We'll make a diagram. Diagrams are very useful models. Helps us visualize what happens and what order it happens in. The other thing that visual models like graphs and diagrams do is they allow scientists to communicate scientific knowledge to other people who might not be scientists. Sometimes graphs and diagrams can get abused, and sometimes they can be made to show things that aren't actually there. But for the most part, graphs and diagrams are very, very useful models for communicating scientific information. The model that is most near and dear to my heart as a geologist, however, is the map. A map is an incredibly powerful model because we can take a map which shows space. It's a representation of physical space. And then we can use symbols and colors, and we can make maps that show all kinds of things. I could take my ozone data and make a map of ozone concentration, how much ozone is in the atmosphere. Maps are super duper useful. And they can show all kinds of information about all kinds of subsystems. I could take a map and show information about the hydrosphere. I could take a map and on top of that map, I could add information to show population densities of organisms. Now I'm using it to model the biosphere. I could take a map and add information to it to show where the water is. Now it's a representation of the hydrosphere. So on and so forth. Maps are models. Models are tools, and it all exists to show scientific knowledge. That's about it for Chapter 1, Unit 2. We will see you on the next series of videos, which will be Chapter 2. Take care.